Hey everybody, Dr. Phil here. This is going to be a video on operations analytics. So looking at how data analytics is kind of used in the realm and the area, if you will, of operations. All right, so let's jump into it. So let's start by talking about operations. So we could define operations as the processes that turn inputs into goods and services that companies sell. It ensures that an organization's materials, labor, and other inputs are used in the most effective and efficient way possible. So, branches of operations. First is the supply chain. So, the supply chain is responsible for the production of a product and service and its distribution to the final consumer. Human resources manages and develops the workforce, and IT operations manages IT hardware, software, and support. So operations analytics is designed to create data-based, actionable insights to help companies optimize their decision outcomes. So HR analytics, often called people analytics, workforce analytics, and also talent analytics, analyzes human resource data to improve a company's workforce performance. IT operations analytics analyzes company data from various applications, devices, and IT infrastructure to help managers identify, predict, solve, and prevent IT related issues. And supply chain analytics analyzes company data to help managers improve supply chain planning, efficiency, and effectiveness. So, types of operation questions. So, if we start with descriptive, again, that's in the context of like what happened, what's happening. Um, a human resources related question could be how many employees does the company have? Like, what's the headcount? An IT operations question could be, what is the average transaction response time? And then a supply chain question could be, which vendors are the top suppliers in terms of dollars and units? For diagnostic, um, again, that's kind of speaking to the like, why did it happen? Why did it happen? A human resources sort of focus question could be, why has headcount changed from the past year? An IT operations question could be, why did average transaction response time increase? And a supply chain question could be, why did quantity used product change? So for predictive, again, this is in the realm of like what will happen in the future. A HR question could be which employees have the highest probability of quitting. An IT operations question could be which system will have performance issues. And a supply chain could be what will product demand be in 2 years. For prescriptive, what should we do based on what we expect will happen? So a HR related question or a HR themed, maybe a theme question. How many employees does a company need during the holiday season? An IT operations question could be, as an example, which solution will solve a current systems problem? And for supply chain, an example question might be, where should manufacturing plants and warehouses be located? So these are some sources for operations data. So human resources data, job applications, websites associated with that, ERP, enterprise resource planning systems for HR and payroll, human resource management or HRM systems, IT operations data, so like system performance data. So for example, like logs, network traffic and cybersecurity analytics, service performance data on help desk, change management and incidents management. Supply chain data, so things like supply chain management, SCM systems, forecasts, orders, tracking, warehouse management, and shipping. And then for descriptive analytics, again, characterizes, summarizes, and organizes features and properties of the data. So just to pick a couple from here, if we pick, say, graphs, bar charts, histograms, so the purpose is to provide a summary visualization. How many employees are assigned to each location? What's the average number of users on each system for a month? And what is the average lead time for each supplier? And then if we compare that to, say, ratios, ratios, of course, compare to numbers. So for human resources, the question might be, what is the employee turnover rate for the year? For IT operations, it perhaps could be, what is the ratio of open versus completed service tickets? And for supply chain, it could be, what is the supply chain fill rate? So KPIs, key performance indicators, you can think of these as numerical metrics used to gauge company performance. They're an integral part of descriptive and diagnostic analytics for operations. Each company determines which KPIs are the most crucial and desired breakdown. So things like channel, product, regional store. And for descriptive analytics, we can examine KPIs at one point in time. So some common operations KPIs. I'll just go over a couple of these. So perhaps productivity. We may measure that for IT operations by response time. If we're looking at supply chain, we could perhaps use delivery analysis to measure that. If we're looking at, say, turnover rate, we might look at SLA analysis for IT operations. We perhaps look at supplier analysis for supply chain. And then maybe just to go over one more, like new hire cost, IT operations, we might use security breaches to measure that. And then for supply chain, we may use product returns to measure that. So diagnostic analytics is basically broken down into two broad categories to help determine why something happened. So the first is identifying anomalies and outliers, something different than we expected, and then finding previously unknown linkages, patterns, or relationships between variables. So we could perhaps perform root cause analysis. We may also choose to, or so to say, and or choose to perform statistical analysis. So things like drill down, drill ups, drill throughs. We also may wish to look at how our key performance indicators change over time. So identifying anomalies and outliers. So what's the expectation? So if we're looking at HR, the expectation might be that annual employee turnover will be 5%. However, it's 15%. So the possible explanations could be that the company's salaries are below the industry average. That's, of course, driving the higher turnover. IT operations, the expectation might be that monthly server downtime will be 30 minutes, but the server downtime for the month of May was 2 hours. So a patch to fix server issues was not applied. That could be an explanation. And then for supply chain, the average freight cost per ton mile will be $18.80, but the average freight cost per ton mile for September was significantly more and higher at $30.66. So the possible explanation for the anomaly could be that more freight was shipped using airplanes instead of trucks. And here we see some diagnostic techniques to find the anomalies and some, associated example questions as it pertains to operations. So if we look at, say, correlation, just to pick one out. The use could be to determine the extent to which variables are related to each other, like how correlated are they to each other. So a HR application could be to what extent is employee satisfaction related to customer satisfaction and sales revenue. For IT operations, it could be to what extent is system response time related to the time of day. And then for supply chain, to what extent is on-time delivery rate related to the season. If we look at some diagnostic techniques to find anomalies, we might, for example, want to use a regression. This, of course, is examining whether there's a relationship between an independent input, the independent variable, and a dependent or outcome variable. So an example could be, how is training related to employee turnover? So that would be like the example question, if you will. How is IT service ticket resolution related to employee satisfaction with IT operations? And then how is weather related to demand from the standpoint or in the purview of supply chain? So for hypothesis testing, the first thing we would do is specify the question. So have the supply chain KPIs, key performance indicators, changed over time? So our H sub zero, that's of course our null hypothesis. So there we're saying that 1991 KPIs are equal to 2021 KPIs. So we're saying that's like a statement of no change. And then the statement of change, if you will, is H sub A, which is the alternative, or we sometimes call that the research hypothesis, which says that 1991 KPIs, you notice we've got this equal sign with a line through it, which just means not equal to 2021 KPIs. As far as predictive analytics go, they're going to help us answer questions such as what will happen in the future? What is the probability something will happen? And can we forecast what will happen? Using historical data and user-specified algorithms, human instructions on how to combine the data, we can think about, what's the likelihood that sales might be this? What's the likelihood they're more or they're less, right? And then, how do we sort of react to that, if you will? So predictive analytics techniques addressing operations questions. So here we just see some examples again. So if I just pick, say, forecasting, forecasting predicts future values based on past values of the same variable, anticipates the behavior of many people, things on long timelines. So an HR application could be, what will employee turnover be next year? IT operations may be how many active users will be using a specific company system in 2 years. And supply chain could be what will customer demand for a product be next year? For regression, the first thing we might do is specify the question. So in this example, the question is, what is the total manufacturing cost for a given number of units produced? So the total cost is basically a function of the production units. And then you see, just as an example here, get too much into these numbers, but you notice that we have our summary output. So we have a multiple R and we have R squared. We have adjusted R squared. We have a standard error. And then we also have, which is important, the number of observations. And obviously, the more observations you have, then the better it's going to be. We notice for when we look at the ANOVA section, it's the significance is it appears to be very highly significant. We have a very strong F statistic here. With respect to forecasting, again, specify the question: what is expected demand for 2022 at each warehouse? And what they have there is a time series 2017 through 2021. You can see along the bottom here. And this is generated, this graphic anyway, was generated by Tableau for a 95% confidence interval. So it's kind of using, again, it's using past data to help predict what will happen in the future. Defining prescriptive analytics. So we answer the questions, what should we do based on what we expect to happen? And how do we optimize our performance based on potential constraints? And then hopefully recommend a course of action. So some prescriptive analytics techniques you can see here, again, in the operations realm. If we just take a look at, say, cash flow analysis, this evaluates future cash flows for potential investments or expenditures. Typically uses NPV, net present value, or IRR, internal rate of return. So here, the application could be for human resources, should a new training program be implemented? For IT operations, which computer system should be implemented? And for supply chain, how many delivery trucks should the company purchase? And then the last thing I wanted to talk about was just quickly was optimization. And just, it's a term you hear a lot. And it just simply means making something as effective as possible or as improved as possible. So in this example, the question could be, what are the best shipping routes to minimize cost and meet demand? So this is something that this was done in Excel by Excel's the solver add-in. And it's just a simple transport optimization problem. And it's just kind of looking at, all right, what's the best route, kind of route minimization, if you will, that helps us to, well, maybe I should say that a different way, like route cost minimization. Presumably the shortest route will be the shortest cost, but that's mostly true, but not always. And then the system is determining, what sort of combination and permutation will give us the lowest cost. Yeah, so make something as effective as possible. So in this case, the minimized cost was 14,599. So, it's examining all these different routes and it's saying, all right, what's the best combination of routes to help us get the cost down to the lowest possible point. All right, as always, thanks for watching, and I will see you all in a future video.